Good morning everyone, and welcome to today's worked exam answer video. This morning I'm having a look at a GCSE question, and I apologise because it feels like quite a long time since I did a GCSE question. And I've chosen, this is an Edexcel iGCSE question, but it covers content that will appear on both the Edexcel iGCSE Paper 2 exam next week and also the AQA Paper 2 exam next week. So we're going to have a look at some organic chemistry. We're going to have a look at esters and polyesters specifically. Okay, so the first part of the question tells us that we are going to be reacting propanoic acid, which is our carboxylic acid, with methanol, which is our alcohol, to form an ester. First thing we have to do is give the name of a suitable catalyst for this reaction. So this is a piece of factual information you're just going to have to recall. And in the preparation of esters, we use concentrated sulfuric acid. And it says name, so I need to make sure that I give the name rather than the formula. So always check that. So that is always the catalyst used in making an ester. And when we're making an ester, we will always need a carboxylic acid and an alcohol. So I know that propanoic acid is a carboxylic acid because it ends with the oic acid, and obviously the acid part is a big clue. I know that methanol is an alcohol because of the ol at the end. Now, in terms of how we're going to join them together to work out the structural formula of the ester, if you need to draw them out first, please do, and I'm going to draw them out so that you can see how I'm going to put them together. So propanoic acid, 3 carbons, prop, and then the functional group for a carboxylic acid is that the end carbon will be doubly bonded to an oxygen and then singly bonded to an oxygen, which is then bonded to a hydrogen. So that is my propanoic acid. And then methanol, 1 carbon because of the meth, and then an alcohol group is an OH, like that. Now I've purposely chosen to draw the methanol that way round so that the OH is next to the COOH, because it is these 2 functional groups that we need to amend and join to give us the functional group of an ester. So the functional group for an ester contains the C double bond O from the carboxylic acid, and then it contains the C single bond O, where the oxygen comes from the alcohol. So that means that we need to get rid of the OH from the carboxylic acid and the H from the alcohol. They go together to make water, which is the other product that we make when we form esters, and then that C with the double bond oxygen then forms a new bond with the oxygen of the alcohol. And then from there, everything that was originally on the methanol is still there. So a carbon with 3 H's. And then on the what was original carboxylic acid, we then had another 2 carbons with 2 and then 3 hydrogens, like that. And I would always recommend drawing out structures before you try and either figure them out in structural formula, or if it asks you to give it as a structural formula, I'd always encourage you draw it out. So from here we can see that the structural formula would be CH3, so that rules out A, CH2, so that rules out B, then a COO, so that rules out D. So therefore it has to be C, and then after the first O, second O, CH3. So structural formula, we just work from left to right, and we start with a carbon and then we say what is on that carbon. So 3 hydrogens, then carbon, 2 hydrogens, carbon, 2 O's, and then a carbon with 3 H's. So the right answer here is C. Perhaps the other most commonly wrong answer would be A, and A would be done by thinking that we joined the CH3 of the alcohol over here and then the rest of the carboxylic acid on the other end, but carboxylic acid part comes first, up to the C double bond O, then the O of your alcohol, and then whatever is after that. Okay? And that's then really helpful because we're also going to think about polyesters. Polyesters, poly, type of polymerization. It's not the same as when we join alkenes together. That would be addition polymerization. The name for this type of polymerization is condensation. Polymerization. And condensation is used when, or is used in reactions, when water gets removed. So for the next part of the question, give the name of the other product of this reaction. It's going to be water. And that is because when we make a polyester, same as when we make an ester, we have to take the hydrogen off of the alcohol group and the OH off of the carboxylic acid functional group, and then that's going to give us our water. Okay? Now, when we joined these two reactants together, we only made one ester linkage. So if we want to make a polyester with many ester linkages, we're going to need to have the carboxylic acid functional group on both ends, and we're going to have the OH alcohol group on both ends, so that, like in an addition polymer, we can join many monomers together. That is one individual compound, and there's no way that I could extend that particular ester any further. However, when we have the COOH on both ends, we can take the OH off of the carboxylic acid from both ends, and we can take the H off of the alcohol group off of both ends. And then, like I did here, we're going to join the C double bond O of this dioic acid here with this oxygen from the diol here, and then we can show on the other end that there would be an O with a trailing continuation bond and a C double bond O with a trailing continuation bond, which will then indicate that this could then join on the other end here, and one of these can join on the other end here. So in terms of the amount of water made, we always make 2 lots of water for every 1 repeat unit we draw, because we've got to take off both ends. Okay, so this is called ethane dioic acid. So it's like ethanoic acid, but the other carbon also has a C double bond O OH. So 2 carbons in total. Di means 2, and then oic acid because they're both carboxylic acid groups. Ethane diol, it's not just ethanol. That would be if we only had 1 OH, so we need the di to show that there's 2 of them, and then they're both alcohol groups, so the ol at the end. Now that's all going to help us to draw the displayed formula for the repeat unit of the polyester that forms. So starting with, and it doesn't matter which one we start with here, but I'm going to stick to the same sort of logic that I did with my ester. And if I've got rid of this OH, the first thing I'm going to have is my trailing or continuation bond to the carbon with the C double bond O, which is that one there. And then next to that, I have the other carbon double bond O, and then that OH has also come off. The C double bond O here is therefore going to join onto this oxygen here. And there's my ester linkage there. And then that oxygen is bonded to a carbon with 2 H's. And then another carbon with 2 H's. And then we still need to draw the O on the other end. The hydrogen only has been removed, so O and then your trailing bond. And that is your repeat unit. Now, if I chose to then add another one of these monomers over here, the first thing I would draw would be an O, and that would then give me the C double bond O and then C single bond O, which is the functional group of an ester. And if I was to draw another one of these monomers, so the ethane dioic acid on the other end here, we'd have next to this oxygen the C double bond O, and then we'd have another ester linkage. So that's why these are polyesters rather than these, or this example rather, that was just an ester. If we're getting a bit stuck with all of this more complicated organic chemistry stuff, my advice would be bring it back to what functional groups do I need to have in different types of compounds, so alcohols, OH, carboxylic acid, COOH, esters, COO, where there has to be at least one carbon then on the other side of the O, so it's not a carboxylic acid. And then go back to naming principles, so methan, ethan, propan, butan, pentan, hexan, all of that kind of stuff. And maybe don't focus on condensation polymers initially, nail all of the other organic stuff, practice drawing those sorts of things first, then move on to the more difficult examples. But if anyone's struggling and I can help in any way, you've got some specific questions you want to send through to me, then as always, please do. I hope all the revision is going well. Obviously it's still a week till the next chemistry paper, but I appreciate that you'll probably have a lot of exams between now and then. So good luck with all of those as well, and I will check in soon. Thanks for watching, guys. Take care.